Hello everybody, John here. I'm going to walk you through some of the practice midterm test questions for Math 55. This is part one of two parts, and they are units 3 and 4 in WAMAP. So this is a sample of what some of the questions will look like. And there's a link down below to WAMAP. And there's also a link to the GED formula sheet, which looks like this. And you can use this formula sheet on any tests that you take with me. And if you take the GED, if you're planning to take the GED, you can use this sheet on that test as well. So it's a good idea to know it pretty well. The first side is geometry, there's perimeter, area, and volume. And then we've got some data and algebra questions. A little bit more geometry here, and simple interest, distance formula, total cost. So you could have questions like those on the GED, and you may have some questions like that at WAMAP or at Con when you're practicing. So if we go to the practice test, I'm going to answer work these first three problems for you, and we'll start here with negative 9x plus 8 is equal to 4x minus 3. We need to solve for x, and so that's what we're going to do over here on the whiteboard. To solve for x, we need to combine. We end up combining like terms, and we're going to use inverse operation. Inverse operation. So the inverse of addition is subtraction, and the inverse of multiplication is division. And as long as you remember to use the inverse operation, you'll be good. Oops, and this isn't updating. Let's pause this for 1 second. So I had to pause the video for a second because my tablet wasn't updating to the screen. So it's updating now, and I was talking about inverse operations, and that's how it's a fundamental principle in algebra. We pick the opposite. If something's being added, we subtract, and if something's being multiplied, we divide, and we do that with the same number. And what we're trying to do is isolate x so that we have all the x's on one side and all of the constants on the other. And we just whittle it down until we're left with x equals something. So first thing we're going to do is move this 8 to the other side. We do that by subtracting 8 from here. And we have to subtract 8 from both sides, or it won't be an equality anymore. So these cancel each other out, leaving negative 9x on this side. And then over here we have 4x minus 3 minus 8. So negative 3 minus 8 is going to give us negative 11. And if you don't know how to do that, search negative numbers at Khan Academy, and you can work on some problems with negative numbers. And now we're going to deal with the 4x. 4x, we have positive 4x there, so we're going to use the inverse, which is negative 4x. We're going to put negative 4x here and subtract 4x from 4x. And whenever you subtract a number from itself, you get 0. So there's nothing there. That leaves just negative 11 on this side. And then negative 9x minus 4x gets you more negative, so negative 13x. Right? And you can imagine a number line at negative 9 and going to the left 4 more places to be negative 13x. Or you can imagine the negative sign as like a form of unit. You've got 9 of those and 4 more of the same. So that's going to be much more negativity. So you combine those numbers and they're negative. So negative 13x. So I think we're one step away from our answer. Negative 13x is equal to negative 11. So what we have to do now, x is being multiplied by negative 13. And the inverse operations property tells us we should flip that on its head. We should divide by negative 13. So if we divide by negative 13, we have to divide this side by negative 13 also. And when we divide any number by itself, that leaves 1. So negative 13x, you've got negative 13 x's. You're going to break those up into 13 groups. You're going to be left with just x. So the negative signs cancel each other out when you divide like that. And this is equal to, and then we can write this double negative fraction as a positive fraction, 11/13. So x, this is the answer. X is equal to 11/13 or 11/13. And we can demonstrate this. If you're taking the test, you won't have time to prove it, but I'm going to show you that this is the correct answer. You would just fill in your answer here, 11/13 here, and it will show you the formatting. That looks good. And let me just work this problem back in. We're going to substitute 11/13 because this is our x value. We're going to put it in here for this x times -9, and we're going to put it in here for this x times 4. We're going to rewrite the equation, -9 times 11/13 plus 8, and that's supposed to be equal to 4 times 11/13 minus 3. Okay, so let's see if it is. -9 times 11/13, and we're just following PEMDAS here. If you want to go along and count out the hey, honestly, there is a multiplication operation not written there. There is an addition operation here. There's another unwritten multiplication operation and subtraction. So according to PEMDAS, we would start with the multiplication. -9 times 11/13 is -99/13 plus 8, and that's going to be equal to this other side. So how much is -19 plus 8? How do we add these two together? So what we can do is change 8, rewrite it as a fraction, 8/1, and then we can make an equivalent fraction with 13 as the denominator, and so we would get, that would become -99/13 plus, and we've got 8 times 13, which is 80, that's 104/13. So -99 plus 104. We have two different signs. When you're adding or subtracting and the signs are different, we take the difference between the numbers, which is 5. And because 104 is bigger than 99, we're going to use the sign from 104, and that's a +5. It's not written there, but I'm going to just put it here. And the units were 13ths. So 5/13 is our answer on this side. And so what we want to see is if this becomes 5/13 on this side too. Okay, so let's just circle this. Let's use a bright color. 5/13. And so 4 times 11/13 is going to give us 44/13 minus 3. So 3 we can write as a fraction, 3/1, and then we have 44/13 minus, and if we multiply the top and the bottom, the numerator and denominator, by 13, we will get 39/13. And then 44 minus 39 is 5, and the units is 13. So these are equal, so that is the correct answer. So we'll go ahead and proceed to the next problem. All right, so now we've got 4 times 6y plus 1 plus 11 is equal to 2 times 3y minus 5 plus 25. So this problem is similar to the last one we did, except we're going to run into the distributive property, which is very useful. Distributive property, when you are multiplying a polynomial, this is a polynomial, or these are binomials actually, but also polynomials. Multiplying numbers in parentheses like this that are binomials, we have to distribute this 4 because it's 4 times both elements, 4 times 6y, and 4 times 1. Okay, over here we have to do the same thing, 2 times 3y and 2 times -5. Okay, and think of these, this is an operation, -5, but if we think of it as -5, this is like a +2, +4. That will help us if we just use the sign when we multiply. we'll use that operation as the number sign. So on this side, we're going to expand. 4 times 6y is 24y, plus 4 times 1 is 4, plus 11, and that's equal to 2 times 3y, which is 6y. And then we've got 2 times negative 5, that's negative 10, plus 25. So now we have to combine like terms, right? And if that's a struggle for you, you can search this term, combine like terms, at Khan Academy, and it will serve up problems and videos, and you can watch those in several languages. So you can come to me also with questions or turn to the Math Learning Center. The links are all in Canvas. So we're going to combine like terms now, which means in this case, we have some constants, just regular old numbers. We have positive 4, positive 11. That's going to give us positive 15. So 24y plus that is going to be equal to 6y. We have negative 11, positive 25. So these are being combined. The signs are different, so we take the difference between 25 and 10, which is 15. And 25 is bigger than 10, so we're going to take the sign from the 25, which is positive. So we end up with 6y plus 15 on the right, okay? Now this becomes just like the, well, it's a lot like the problem we just did. Negative 9x plus 8 is equal to 4x minus 3. So this made it a little bit fancier, these steps up here. But now we can just work with it, moving things around. So let's go with purple. We're going to first, I like to leave, when we isolate the variable, or in this case the variable's y, we're going to isolate y. I like to get rid of all the stuff at the periphery. So this 15 is going to go. I'm just going to subtract it, and works out nicely because it's the same on both sides. So 15 minus 15 is 0. 15 minus 15 is also 0. So 24y is going to equal 6y. And then we just have to combine our terms. Let's get a different color. And here we've got, we're going to subtract 6y and subtract 6y from this side. And we've got 18, that leaves 18y is equal to, and this has 0. 18y is equal to 0. So this might be kind of a trick question, but if 18 times y equals 0, if we divide both sides, which is what we're supposed to do, right? We take the inverse operation. Inverse operation rule says we're going to, this is multiplying by 18, we're going to divide by 18, and we have to do that on both sides. So this becomes y, and 0 divided by 18 is 0. So y has to be equal to 0 in order for this to be equal. So let's try plugging that in and seeing if that's correct. Let's grab a new color. How about blue? So if we substitute 0 in for here, we'll have 4 times 6 times 0 plus 1 plus 11. And that's supposed to be equal to, I'm going to write it down here in a different color. That's supposed to be equal to 2 times 3 times 0 minus 5 plus 25. And these numbers should be equal if our answer is correct. So let's take a look. So PEMDAS says we have to work in the parentheses first, and we do have, there's multiplication here, not written, multiplication here, also not written, there's addition, and there's addition here. So we have 4 operations, 2 are within the parentheses, so we're going to start there. We're going to go here first, and then we'll do the addition, okay? So let's go ahead, we'll do 6 times 0 is 0, plus 1. So 0 plus 1 is 1. 4 times 1 is 4. All right? 4 times 1. Did I skip too many steps for you? Let's go back and go step by step. So 0 plus 1 is 1. 4 times that, plus 11. So 4 times 1, we evaluate this to 4, and that plus 11, that's going to give us 15. Okay? So we would expect to find 15 for the other one. Let's take a look at the operations here. There's multiplication not written, and another multiplication, and subtraction, and addition. So we've got 4 operations. This is a four-step order of operations problem, and we have to start inside these parentheses, right, with multiplication. So 3 times 0 is going to be 0. 0 minus 5 times 2 plus 25. I'm sorry, that looks like a negative, but it's not. All right. And so 0 minus 5 is negative 5 times 2 plus 25. And so 2 times negative 5 is negative 10 plus 25. So we are combining two numbers with different signs. So we are going to take the difference between them, and it's 15, right? The difference between 10 and 25 is 15. And then 15, the bigger 25 is the bigger number of the two, 25 and 10, and the sign on 25 is plus. So there we have plus 15, and our other answer was plus 15. So that's the correct answer. So that was a lot of work just to find out that the answer was 0. But when you're taking the midterm, watch for this kind of problem. They will try to trick you, but it's just a way to keep you in shape mathematically.